All right, everyone. I am here with Yunyao Li. Yunyao is a senior research manager with IBM Research working on natural language processing. Yunyao, welcome to the TWiML AI podcast.
Thank you so much for having me here.
I'm looking forward to digging into our chat. We'll be talking, of course, about NLP and some of your experience on the research side, as well as making it useful for IBM's enterprise customers. To get us started, I'd love to have you share a little bit about your background and how you came to work in the field.
Sure. So as you mentioned, right now I'm a senior research manager at IBM Research. Before that, how did I get there? It's actually a long story. So I have to say, I grew up in a small town in China, right? Before I went to college, I didn't not even see a computer. But when I picked my major, I picked the major of automation because I thought if I automate everything, I don't have to do anything. Okay. So that's like the start of really think about AI helping people. Then
Okay.
when I went to college, I also did a second degree. I did a dual degree. I did automation and economics because I want to understand how technology impacting people, impacting the society. Then I went on to come to US to pursue my graduate studies. So I did two master degree again. I did one in computer science, another one in information science because again, I want to understand the technology itself, but I also want to understand how technology impacting people. So my information science more focused on HCI side and information economics. Then I pursue my PhD in database. However, it's not a traditional database PhD. So what I did was to enable people to query database using natural language. So that's basically one of the hottest topic today in natural language processing. So
Mhm.
I would say my connection with AI basically started from the very beginning of when I started my higher education.
Nice, nice. And uh, now, as a senior research manager, talk a little bit about your research interests and more broadly the role. And it sounds like you're focused on kind of traditional research, but you also have these customer engagement element to your role. Can you talk a little bit about that?
Sure. So my general research interest is quite broad, but in general, I'm very passionate about building systems and tools to enable people, wide range of users, to be able to use technology. In particular, since I work in the field of natural language processing, my passion is really to empower people to harvest information from text to build the next generation of AI applications. So within IBM, we have a lot of product based on natural language processing capability, like what's an NLU, what's an discovery, and so on. So behind this technology, I'm very proud to say a lot of the product are powered by technology developed by my team. So really empower the product themselves. Meanwhile, when we have things in the lab, they may not always mature enough to put in a product yet. So then we also often engage with customers and also our technical sales team to say, okay, for this particular problem, we don't have a product yet. What can we do for the customer? And that really helped me to understand what are the key challenges that we need to address from research point of view. I think that in my mind, as someone working in industry research lab for over 10 years, right? I really enjoy that because when I was in school, kind of you always need to think about what's the motivation behind the work. Here in industry research, I don't have that problem. The problem come to me. And then the interesting part is how do I generalize one person's specific problem into a research problem that can be solved in a staged fashion, like both very ambitious from scientific point of view, but at the same time we deliver things as we go.
Yeah, well, I want to dig into some of the specific challenges that you've identified in the NLP domain, but projecting from an individual customers challenge to kind of a broader, interesting research problem is one that I'm also interested in. Can we maybe start there? And I'd love to get your take on that.
So maybe I can share a story, right? When I joined IBM, I work on a project called System T. So
Okay.
System T is a declarative system for natural language processing. And I have to say, to a certain extent, I'm still working on this system. The reason is that when we have a larger research agenda, we cannot solve the problem at once, right? So, for example, how system they come into being. That's because at the beginning we want to build a better enterprise search system. So when we're trying to support enterprise search internally within IBM, we found the traditional IR system do not understand the document enough. But one thing that it differentiates internet search and internet search is in internet search, when you try to find the answer to a question, maybe it's only have one page that has the answer. Unlike when you do a Google search on the internet, when you search for a certain question, right, you may have hundreds of pages. So then in internet, it's really important to understand every single document, and that really motivated the team to build a natural language processing system. And then at that point, what we found is there are a lot of problems in creating natural language understanding system, but the most basic one is really, like, for example, the do information extraction, identify important entities, identify important events, and so on. But at that point, we don't have a very scalable system to perform the task. So then we start building the system T, where we kind of abstract out what are the common text analytics operations that we need to capture. Then we build a system. At the beginning, our concern is about expressivity and runtime performance, to be able to express the kind of tasks that are important for supporting enterprise search. Then as we go, we find out, okay, we can build a system that is really good to building extractors for supporting enterprise search. But then we want to enable more people to use them, right? Then we kind of say, okay, now we have problem of how do we build a better tooling into it? How do we incorporate more advanced machine learning capability into it? So kind of at a different period of time, we have different focus, but overall, because we have this one bigger project, we can build one thing on top of the other. So I think that's really the advantage of working in an industry lab where our research is not bounded by a fixed period of time for grant, right? But this kind of generalize the overall life cycle. Like we have a concrete business problem. For example, we started of how do we support a better enterprise search, right? Then we turn that into like how do we build a system to support a class of such problem, and then we solve some of them. We build some prototype. We evaluate with concrete use cases, and then we get a feedback. When we can solve certain kind of concrete problems, we can push it out into the wild, and then we get additional feedback from the wild. Then we incorporate to say, okay, now we have this system. Should we focus on improving the system itself, or should we focus on the tooling? Should we focus on other things? I think a lot of the work from the team really kind of come with the same life cycle.
Well, let's maybe jump into some of the challenges that we referenced earlier. When you are thinking about and trying to help teams productize NLP in the enterprise, what are some of the challenges that you run into, and kind of how do you think about those challenges? How have you organized those in your head?
Yeah, so that's a very good question. I would say we can think of four category of major challenges. The one is complexity. Complexity in terms of because we're talking about natural language processing, right? In terms of the complexity of the document we have to deal with, and the complexity of the tasks themselves we have to deal with. The
Mhm.
second category is small data. So again, when we talk about enterprise facing challenges, right? We often have to build things that works for everybody, but we don't necessarily have data that are representing everyone's problem, right? So therefore, we need to be able to address the small data problem either based on what we have internally or have some way to enable people to provide data for us to help themselves. And then the third part is customization. No matter what we build, right, how well we build it, the out of box capability may not be sufficient for a customer specific use case or works as well as it could be on their own data. Then, how do we enable the customers to quickly customize what we build to fit into their use case, their data very quickly and easily? Do not necessarily require someone like me, right? Someone with a PhD degree to work with them. So instead, maybe someone with a business knowledge to be able to do this work on their own. And then the fourth part, explainability. I know, everybody talk about trusted AI and so on these days, right? One big part of trusted AI is explainability. Then here we need to understand what kind of explainability makes sense to what kind of audience, right? And how do we provide variety of explainability to help people? So I would say, yeah, those are the four major challenges we are focused on from enterprise natural language processing point of view.
When you think about those challenges, do you think about them independently? Meaning, do you have a set of solutions or a set of research directions to try to address complexity, and a separate set to try to address small data, et cetera? Or is there a way that you kind of unify these in the solutions that you're trying to apply to these various problems?
Yeah, I would say we have a few common approach, a combination of them to solve all the problems, maybe with different combination. I think the four things we often use are the following. Number one is data augmentation, right? The second is to have a very powerful declarative language that captures some of the main primitives that are important for to conduct the task. And the third one is neurosymbolic AI, really leverage the best of both worlds in neural network as well as the symbolic system. And the fourth one is human in loop. How do we involve human beyond just provide labeled data? So those are the four things that the business secret formula that we have been following. And then for solve different challenges, we may use a combination of two of them or three of them.
Got it. Got it. I want to go through those in turn, but maybe to set some context, it'd be helpful to have you talk about, some specific challenges and where each of those comes in.
Sure. I think maybe I can describe a particular system we have recently built, and I think the system kind of representative for all the challenges. So what we have been working on with the Watson Discovery team was to build something called Watson Discovery Content and Intelligence. What this system does is to enable lawyers and law professionals to quickly review contract document. If you think about contract, right? It's probably one of the most important business document in the business world. And it's very expensive to review those contracts because you need to hire legal professionals, and the contracts often have many, many pages and contain a lot of information that is challenging even for you and me to understand, right? So, to build such a system, what is required? First of all, the first step is a lot of contracts are in PDF format, so we need to convert the PDF into a form that is consumable by the machine, right? Then secondly, we need to build models to simulate what the non-professionals would do so that we can help them, right? So what contract understanding involved on the high level is the following. Given every single document, identify the clause. For simplicity, you can think of sentences. For every single sentence, identify what are the categories of that particular sentence and what are the parties involved in the sentence. For example, if I say the buyer shall pay supplier $1 million, right? So in legal terms, this is an obligation, and the party involved is a buyer and a supplier, right? And then there is some amount. Then we turn this into a sentence. First of all, identify the sentence, right? Identify sentence from the document, and then do a classification so that we can categorize this sentence and also do extraction to extract what are the parties involved, like supplier and buyer. Um, so now, then once we have this system built, it will not work perfectly, right? So we need to surface it to a legal professional so the legal professional can say, okay, now I want to review all the clause related to obligation and then look at those sentences and to be able to say, okay, this is indeed an obligation. I want to do something, right? Mark it as high risk or low risk or no problem. But think of the challenge we just mentioned, right? Complexity. First of all, the the complexity involved in the document itself. The document is a multi-page PDF document that we need to preserve all the structure, all the information, and also be able to identify. Like assuming the document conversion is correct, we also need to identify the document structure and to be able to identify individual sentences and the context, right?
Right.
Um, then why it's a small data problem? Because when it comes to contract, nobody gonna share their contract with IBM for us to create training data, right? So if we want to build a model, we have to rely on IBM contract data, but at the same time, what we build need to work for other people, right?
Mhm.
Then why it's a customization problem? Because even though we're talking about the the legal professionals follow some general taxonomy related to the classification, every single company they may have some difference. For example, if a sentence mentions patent, right, or a trademark, it can be viewed as a clause related to intellectual property. But some
Right.
company want to separate them. They want to say, okay, I identify all the clause related to trademark as trademark, but
Yeah.
everything else related to intellectual property is intellectual property,
Okay.
right? And then finally, explainability. When we surface the results to the legal professionals, we also need to, especially when there's a mistake from the prediction, we need to explain to the legal professional like why we predict this sentence as something, right? Like this is obligation rather than something else. We need to explain that. And also, what that will help us is when they say this is not correct, we can also look into potentially how to fix them. And they can explain to us, okay, why certain things is not labeled correctly. Like what I just described earlier related to customization, right? When they come back to say, oh, this sentence should be labeled as trademark instead of intellectual property, they can explain to us to say, okay, for this particular thing, you identify this clue related to trademark, but in our company, this is regarded as trademark rather than intellectual property. So they also help the model developers to make some changes. Um, yeah, so I hope this example kind of illustrate all the different thread. But I will also be happy to talk about, how do we solve them.
Yeah. Yeah. Well, we'll definitely do that. One question that does come to mind. Yeah, I've talked in the past with folks that are working on these production NLP systems, and over time the need to supplement the learn models with rule based systems and heuristics has decreased. And I'm curious, in the cases
Mhm.
that you deal with, in addition to the data augmentation, declarative, neurosymbolic, human in a loop, do you also need to, are you still worrying about, rules and exceptions and all of these things as well? And do you see those decreasing over time?
I think depending on the use case. So, for example, for some use case, when full explainability is important, we actually see a requirement to combine both. So let me give you an example, right? So if we think about model development, it has a life cycle, right? We have data gathering, we have developing the model itself, we have test and validation. So for some industry, for example, for retail banking, the fact, the training test and the validation, what we learned is if you use a black box model, right, like a neural approach, assuming you have sufficient data, the training is very fast. Test also will not take too much time, but the validation will take a lot of time. So what they do in validation really ensure the model work as predicted under different variety of conditions, and also be able to explain why certain predictions produce the particular results versus what is expected, right? So this takes a lot of time. Um, but if we use rule-based approach, right, it's kind of opposite. So the developing of these rules take a lot of time. Testing also takes some time. Validation doesn't take too much time. So overall, you kind of see the time and effort distributed in different way. So what my team has been working on is actually kind of getting the best of both worlds. So basically, what we do is we take a neural network, we leverage all the advantage of neural network to be able to learn from large amount of data, right? But then we produce set of rules that are completely transparent and explainable. So the advantage of this, and then a domain expert can actually come in to do further inspection and augmentation to ensure the model not just learn from the data, the model also learn from the domain expert the corresponding domain knowledge, right? So the benefit of this approach is the training will not take as much time as the purely rule-based system, right? It takes similar time as the whatever approach we are taking for black box model. Testing is also similar, but the validation takes significantly shorter amount of time than if you take a black box model. Um, Depending on the use case, right? In some use cases, you really don't need to have full explainability. Then I think, yeah, using neural model probably is the way to go. But in the use cases where explainability is important, it's important to hold someone accountable when the system make mistake, right? So then this approach works really well. Another aspect is, remember what we talked about a small data problem, right? So the issue is, no, yeah, in a lot of the area we don't have sufficient data. So when you learn from the data alone, it will not capture the whole domain knowledge, right? So I think what our experience, the domain experts really like the fact they can not just provide input by labeling, they can also provide input by inspecting what learned from the model and make changes, not just to understand how model perform, but able to make changes. For example, simple things like what I just described earlier, right? To say, okay, buyer share, pay supplier $1 million, right? A potential rule that we can learn is when there is a predicate indicating, like a verb indicating purchase, indicating some business transaction, and then there is a model, there is a modality of necessity modify that particular verb, then it's potentially an indication of obligation. This is something completely transparent, right? We can learn such a rule. But what are considered as important business transaction verb, this can be given by the domain expert, not just by learning from the data, right? We can also let the domain expert to inspect the list of dictionaries we learned, list of rules we learned, so that we can ensure their knowledge is captured by a model. Um, and then we can combine, right? So this model can be then combined with a black box model so that we can really ensure, the overall performance is as good as possible. But at the same time, we're able to predict or explain significant portion of the prediction and how the two models are combined together depending on use case. Like for example, if you want to say, I want to have as good performance as possible, then if I can explain some of the results, that's good. Then we can combine it in one way. Or you want to say explainability is most important to me, right? Then with that, I also want to have good performance. Then you can combine these two in a different way. So I think with this particular approach, we really can get a best of both worlds, be able to leverage the fact neural network is very powerful to be able to really capture a lot of nuances from the data that is very hard to express in rules, right? But at the same time, capture as much as possible the domain knowledge that can be clearly articulated through rules. Another thing I want to mention is the rules are not based on syntactical pattern, right? So the rules are based on abstraction we obtain through natural language understanding. Like for example, given the sentence buyer share pays supplier, through natural language understanding, shallow semantic parsing, we will know there is an action of pay, and then the performer of the action is the buyer, and the target of the action is the supplier, and then the manner is pay with $1 million. So this kind of semantics is captured through advanced natural language understanding. Therefore, we can express rules in a very concise but a very powerful way. I think that's another thing people need to think about. Rules are not necessarily one token for another, right? So traditionally, when we think about rules, is like, okay, well, when you say buyer, maybe follow in two token, there is a supplier, but then that cannot capture the nuance of the language, right? But if we build rules on top of semantic abstraction, they can be much more powerful. And then behind the scenes also leverage the deep learning, right? So behind the scenes, leveraging neural network model to do natural language understanding. Um,
Got it. Got it. And now, just to make sure that we're on the same page, is what you described. I kind of came at it from the perspective of rules, but is this the neurosymbolic uh, AI that you spoke about earlier?
Correct. Yeah, so I think neurosemantic, you can basically think of the two approaches, right? One approach is you embed symbolic information or expression into a neural model, right? That's how people can ingest some domain knowledge into a neural model. But then the neural model coming out is still not completely transparent, right? The other way you can do this is you can use a neural model to produce symbolic model or symbolic abstraction, then we can build a symbolic model on top of it. So right now, imagine we actually have both approach, but what I'm describing is more of a latter, where we leverage neural model to empower symbolic model, because the symbolic model has a lot of advantages that people is fully aware, right? Explainability and and the part where it's easier for people to interact with and understand. Yeah, so this is one particular neurosymbolic approach we have been taking.
And then one of the other techniques that you mentioned was the use of declarative languages. I'm imagining that you've used this neural model to create kind of this abstract rule, let's say, about a particular scenario. You want to make that accessible to, well, the humans in the loop that we also talked about.
Right.
A way to do that is to kind of represent this abstraction using some kind of declarative
Right,
language.
exactly. So I think, yeah, I think that's a very, very good point, right? So you can express rules in grammar, but the challenge is that grammar also dictate how the rules will be executed. right? Then
Hmm.
that makes the rule creation much more challenging and less expressive, and also have runtime performance issue. So we kind of overcome that by leveraging the declarative system we have mentioned earlier, right? Like the system I have been working with since I joined IBM is we can separate execution from the actual semantics. So you can specify the semantics using declarative language, but how it will be executed is determined by the optimizer. The optimizer will determine what's the most efficient way to execute. So, for example, if my rule is to identify all the sentence contains business transaction and include the modality indicating necessity, I can do it in two different ways, right? One is I can identify all the sentences with necessity and then see whether there is a business transaction next to it, or I can do the other way around. Which one more efficient will decided by the optimizer. Like when I created the rule, whether manually or automatically, I don't need to worry about execution. The execution will be done automatically by the declarative system to ensure we get the most optimized plan in terms of execution.
Hmm. And when we talk about execution in this context, what do we mean? We typically think of neural network inference, or even more broadly ML model inference, as kind of this one. You make a request, you get a prediction back. Are you thinking about execution more from the perspective of like information retrieval and queries and that kind of thing?
So here, when we have a rule-based, like based on this kind of model, right? So for example, for simplicity, let's say we do two part. One part is just do natural language understanding. The second part is just enforce the predicates, right? So the execution composed of a few different options. One option is that you perform this natural language understanding operation, the neural model we have, right, on every single sentence. Then for every single sentence, you also check whether it contains any business transaction mentions and also some words indicating necessity. So that's one way of execution. Another way of execution is that I can actually do some optimization. Instead of look at every single sentence, I can first retrieve only the sentence contains the business transaction. Then I perform natural language understanding. Then I check my predicates. So it's really how we produce the final results. So that's the execution I'm talking about.
Got it. Got it. So to maybe kind of recap this and put it back in the context of this original problem where you're trying to enable legal discovery across lots of contracts. Um, one approach one might take is to use traditional deep neural networks, and maybe a supervised learning kind of thing, or even unsupervised, and kind of clustering the different clauses or sentences. Um, but what you've found is that by using the neural network, instead of to classify, but rather to kind of do something akin to like entity extraction, or semantic parsing, you can use that to generate this, essentially a rule set that's kind of expressed in this declarative language, and then you've got a system that executes those rules against a given contract and uses that to essentially make sense of it, and identify whatever it is that you might want to identify at a given time.
Correct. Yeah, on the high level, you can view it that way. But we can also do combination, right? So you can basically think of I can either build a black box classifier, or I can build a white box, or I combine the black box and white box together so that I can get the best of both worlds. So I think in reality, we actually do both. So I think the challenge of doing this black box one, another challenge is the following, especially when we start with building the product, we don't have even a lot of label data. And also, as I mentioned, right, we have this small data problem. We have data from IBM, but we don't have data from other company. How do I ensure the model I build works well? So here, the out of domain performance is very important, right? So what we actually started with multiple different approach, right? You can think about it, in IBM Research, we also build a lot of different neural networks, right? That's really anything that are accessible to other people. We also have it, but when we build those side by side, what we found is that the in-domain performance for the deep neural network works really, really well. But then it drops very significantly when we do out-of-domain. So that really partially motivated us to build more of this transparent model so that the out-of-domain performance is very similar to in-domain. Then we can augment this particular model if we want to have a better performance, to say if we have additional training data, we can also kind of augment this with a black box model. But at the same time, we can benefit from the explainability, transferability, and also be able to really quickly start with a particular customer's use case without worry about training data. Because I think a lot of time, I mean, I'm deeply involved in natural language processing research, right? So if you look at the papers, people often assume we already have labeled data very nicely available, and then right, then if you don't have labeled data, you can just do crowdsourcing. But in the case of enterprise applications, like I cannot even label this data, right? The contextual information is really, really rich. So I remember at the beginning when we built this product, we look at all the sentences, and like two sentences looks almost identical. We go to ask the lawyer to say, okay, why those two sentences looks identical, labeled differently? Then lawyer tells us, oh, because one is within this section with this information, but the other do not, right? Again, like how do you even capture, like let's say you have this information, I can quickly basically code that rule to say, okay, take this section information into account, right? I can do that in a few minutes. But think about, how do I retrain my model to do that? Like now I have to, yeah. So I think in general, I would say depending on the use case, right? There is in my opinion, there is no one solution. We need to really use the combination of all these technology techniques available in our toolkit, and take the practical challenges and also what's the final goal in mind, right? Like for example, in our case, our goal is not to say build the best possible model for IBM contract. If that's my goal, I don't need to have this approach, right? I can just do this training and then have a model that works really, really well for in domain. But our goal is to build a good model for other people and enable them to customize, and that really come to the solution that I mentioned, right? So we want to take advantage of both.
And in describing that solution, you mentioned a lot of different options. You know, the white box, the black box, etc. Um, how do you? I'm wondering, like, where you're making those decisions. Is it, it's not at the level of product because you want, I'm imagining a platform that kind of does, that can handle multiple use cases. Do you have different paths that you go down for different use cases, or am I thinking about this incorrectly? And it's more of, you have this toolkit and you have to apply this toolkit kind of more in a consulting or orientation when you're faced with a particular use case.
I think that a few different ways to approach it, right? One is like, for example, when we build what I just described, this particular offering in Watson Discovery Content Intelligence, it's one offering, right?
Yeah.
And then in that offering, we take this particular approach and then we show it's really useful. But assuming like the customer come to me with something else, then one thing we're actually doing right now is to take more of an auto AI approach where the user give us the constraint. We will figure out based on the constraint they give to us what's the most like what's the optimal combination. Um, so you probably have is aware, right? Like auto ML is kind of a very trendy topic. So, for example, Hugging Face recently pushed out a new feature called the Auto NLP, right? Because even with the black box, you still have a lot of challenges, like which model to use, how do you tune the hyperparameter, and so on, right? So here is actually think about the main parameter we introduce is we have additional type of models and we have additional ways of ensemble them together. And how do we do those could be automated when the user specify constraints. So for example, the user can say, I want to have best performing model with some explainability, right? Or the user can say, I want best performing model. I don't care about explainability, right? Then with those constraints, we can automatically figure that out. This is something we are building in our project called Auto AI for Text. So we're building all these operators that are supporting different kind of model, and different model have different property, right? So then based on the user constraint, we can decide which combination model to use and then which model to refine further, look at it, refine the hyperparameter tuning and refine how do we do the final ensemble.
Got it. Got it. Got it. Since you mentioned the auto NLP and Hugging Face, I'll quickly mention to folks that I interviewed one of the folks who worked on that, Abhishek Thakur, and we'll drop a link to that interview in the show notes. But I want to get back to data augmentation because we haven't really talked about that so much here, and I think it's often easier to think about how to do that in the context of computer vision. Add noise or change the orientation or flip or rotate or that kind of thing. What does that mean in the context of NLP, and how have you included it or incorporated it into your projects?
Yeah, sure. So talking about data augmentation in NLP, actually there is an excellent tutorial or survey paper come out very recently that summarize some of the techniques.
Mm,
I can send you a link later on. But in the context of what we are working on, we do data augmentation in a few different ways. The first one is so I mentioned we do natural language understanding, right? We do, giving a sentence, we parse into some semantic structure. So we have enough data for English to do that. However, for other languages, we don't have this nice data, right? We don't have label data to perform the same task, but we
right.
want to also support other languages. So one technique we have been using in terms of data augmentation is we can leverage the fact there's the bytext. We have sentence in one language like English and then sentence in another language that is translation of the English sentence. We can do sentence alignment, right? Align or each token with each other, and then we can project the annotation we produce on English onto other language. So now we have some very noisy label data to start with, right? Because you can think about the always lost in translation, right? So when you do this projection problem, there are going to be some mistakes. So we also do additional filtering to ensure that uh, the data we produce is as good as possible, and then we can use this data to train a um, semantic parser, a shallow semantic parser in the other language to further augment the data, kind of repair the data. So maybe after projection, for example, in my sentence, I only have some portion with annotation, the other portion we do not. Then we can do this bootstrapping to add additional ones. So this way we can automatically at a scale produce large amount of data. So this is like one way to do data augmentation. Another way you can also do it is, so for example, one of my colleagues, they have been working on dependency parsing for other languages, right? So again, we may not have sufficient data for other languages. So what they have done is they translate the English sentence of other language into English sentence, and then back and forth. So this way you can also produce larger amount of what do we call silver data. It's not gold data because it's still contain good amount of noise. But when you train from this data, the neural model is able to distill the noise and to be able to learn a pretty reasonable model. So a lot of data augmentation in natural language kind of doing this synthetic data or annotation projection, annotation transfer. Um, there are also ways to generate data. Like for example, if you have this actually a recent paper we published in ACL earlier this year. So one of the tasks that is challenging for parser is handling questions because most of the training data for natural language processing are statement, right? News reports and so on. But often we have data loads that actually are questions. So what we found is the parser trend using the typical data set do not work very well for questions. So then what we did, but then label question is very expensive, right? Producing label data for question very expensive. So what we did is there is a data set called a question bank. It has some maybe a couple of thousand sentences and so on. So we basically generalize from those questions from the question bank to generalize into template. So with the template, we can generate a lot of labeled data for question, and then we can add those generated question back into the training data so that the parser can handle question very well. So I think it's actually to great extent similar to what people do in computer vision, right? It's just how you manipulate the data is different because we're using deal with text here instead of vision.
Right. Um, nice, nice. We haven't talked much about human in the loop. I think a lot of folks are familiar with some of the common uses of human in the loop. Of course, exception handling is one that comes to mind. Is that the kind of thing you are referring to when you mention it?
That's a very good question because I actually have a very strong opinion about that. I, I think human in loop is actually very broad, and I can describe a few different aspects. In my opinion, human can be very important as part of the model development process, right? Often
Okay,
when we think about human in loop, it's more about labeling, right? Like
sure.
how do we involve people to provide label data? That's very important. In fact, we have spent a few years trying to figure out how do we enable average person to be able to provide high quality data for shallow semantic parsing, because our initial way of doing this, it shows that the human cannot perform as good as our machine learning model.
Mm,
Then we need to come up with a more intelligent flow to enable average people to do as much as possible, and then enable expert to do the rest. So I think that's one big part of when we talk about a human loop is how do we enable human to generate high quality data, but not necessarily all be done by crowdsourced worker because not every task is possible. But then at the same time, we don't necessarily always fall back to the expert in the loop then. So we need to kind of have crowd in the loop, but at the same time involve, you know, experts or automatic method as much as possible. Then one thing people don't really talk too much related to human in the loop is the model development. The reason is very simple, right? Most of the time when people talk about model development, you are talking about a black box model, right? But when we talk about white box model or gray box model, we want to involve humans in loop in a few different ways, right? One is what I described before. We use deep neural network learn a transparent model. Now human can inspect the model, augment the model, modify the model. That's one big part of human in the loop, right? The second part is maybe the user do not need to give us a lot of data at the beginning. Instead, we can have the model creation and data gathering in one intelligent, simplified mode. Like for example, when I talk about classification of this particular class, right? So instead, the user give me, a few thousand label data, train a model, and then we run it. What we can do is, okay, user may not even specify a task upfront. The user just say, hey, this sentence is interesting. I will label a few interesting sentences as an example, and then let the machine figure out what are other similar sentences, right? But again, the machine may not fully understand what I mean by similar. So the machine will propose some potential interpretation, right? And ask the user to provide feedback. And then as the user provide feedback, the machine can learn a bit more and refine what the machine has learned. And in the end, it will produce a model, but it's a very collaborative process, right? And in between, the user may go beyond just give me an example. The user may even give me rationale to say, hey, why I think this sentence is interesting, or why I think what you propose is wrong. And then it's very interesting to incorporate this kind of what we call rich feedback into the machine learning process. Again, this is like a model development process, right? Um, and then another approach is so as I mentioned before, right, we have this declarative system. Declarative system is actually very good for tasks that have very obvious patterns, right? So rather than trying to let the black box model figure it out, we can specify that, right? But specify that can be expensive. So we can also have this process of user giving example. I can explain to the user in my declarative language what I have learned, and then the user can give me either additional feedback or modify that particular declarative statement directly. So that's like one big part of human in the loop on model development. Finally, about user feedback, right? So how do we enable the user to provide additional input to the system when the system already deployed? So again, that's also an important part. Like where think about today in a lot of system, if the user not happy, you cannot really do anything, right? So the system produce whatever it produce, that's it. But you can imagine a system where, for example, the contract intelligence system I mentioned before, right? When the user sees the output, the user not completely happy with it, the user can explain why she's not happy with the results, right? And then can also maybe provide some additional input to say, okay, here in, let's say for example, in my company, right, we will differentiate trademark and IP. So we can learn from those, and that can come back to our development team to be able to say, okay, is there something we need to address in our baseline model, or there's something we need to address by enable the user to be able to do some customization. So that allows to do much more intelligent model improvement and maintenance.
Got it. Got it. It sounds like the elements of this that you feel most strongly about are kind of a combination of closing the loop. So you put the human in a loop, but then close the loop so that it improves your model, but also as an idea of like intelligent human in a loop. Use machine intelligence to optimize the way the human intelligence is being used in the loop itself.
Right, exactly. I think we need to give a human more agency, right? We need to empower human rather than just, sometimes if you think about it, if all the user can do is give you label data and then leave everything to the machine, the human is almost powerless. You cannot do anything, right? You know the machine is not correct, but as a domain expert, you don't know how to modify the model. You don't know what to do, right? You're kind of waiting. Hopefully, someone will incorporate the data or the knowledge properly. But when we actually give human agency, I think that they can do much more. So, for example, actually, in recent in 2021, we can see a very interesting trend. So in 2021, we see three workshops from top NLP conference
Mhm.
that are related to human and human and NLP. So we have a workshop on interactive machine learning. We have a workshop on NLP and HCI, and we have a workshop on data science with human loop language advancement. And next year in 2022, we are also going to have a special theme in NACO that is focused on HCI for NLP. So
Mm.
basically, more and more, like when NLP become more and more used in practice, human become an important aspect. Right?
Mhm.
When it's just in the lab, all you need to do is produce some numbers and then compare with benchmark data. You don't need to consider human, right? But now when NLP actually impacting business, when it's actually used by people, how do we use people to help with the entire development life cycle, including evaluation and so on, become more and more important, and you can see the trend.
Awesome. Well, Yunyao, thanks so much for taking the time to share a bit about what you're up to and walk us through these four different tools that you've had some success with in delivering enterprise NLP.
Thank you so much for having me here.
Thank you.